Hello, everyone. We are going to talk about rectangles today. Hopefully, we did pretty good. Like I said, this is a pretty simple unit, so I'm very glad that this is the one we're starting with online. So hopefully, everything went smoothly last class. Remember that I do have office hours 11 to 12 every day if you need any help. So first off, a rectangle is a quadrilateral with 4 right angles. And I just want to reiterate, guys, if you have access to a printer and you do want to print these out, you're welcome to and follow along. If you don't, it's totally okay. Watching this video and taking your own notes on a piece of paper is plenty. Make sure you are watching these and trying to interpret it, though. If a parallelogram is a rectangle, then its diagonals are congruent. So I'm going to go ahead and label all the interesting things we see in this rectangle here. So first of all, I have vertical angles here and here. So I can mark those angles congruent, okay? I also just said that the diagonals are congruent, which means that, once again, they're bisecting each other. So if I labeled this A, B, C, D, I know, because the diagonals are congruent, I know that AC, this diagonal, is congruent to the diagonal BD. Okay, it's hard to label that in this picture because they do bisect, but I do know these are equal. Okay, and so are these. These are all equal. They're bisecting each other, cutting each other in half. All of these diagonals are equal. Same with their halves. Okay. In a rectangle, you should also know this from way back when, that these two opposite sides are equal. You'll notice I already used my 1 tick mark, so now I'm using double tick mark. And then these opposite sides are equal. It's not like a square where all our sides are equal. Okay, that's important. The other thing I can say here is you should also know that these lines are parallel. Okay, so if we ignore what's going on in the middle here, okay, just ignore that. If I look at this, I have these two parallel lines and I have this transversal. Okay, this transversal cutting through. So I have two parallel lines and a transversal, which means these angles are congruent by alternate interior. Same thing with these. Those are also congruent by alternate interior. Now, these two angles aren't equal to each other unless this is an angle bisector, which in this case it's not. However, it is congruent to the ones opposite, okay, the ones diagonal. Now, this is where it gets kind of crazy, is if you now ignore, let's ignore some other parts of this problem. I'm using my sticky notes just to kind of help you see this, visualize this. This is a triangle, okay, right here. This is a triangle with two congruent sides. What kind of triangle has two congruent sides? We call that an isosceles triangle, right? So the other thing we learned about isosceles triangles a few units ago is that their base angles are also the same. So the two angles below the two sides that are equal. So if this has 4 tick marks, this also has 4 tick marks. It's also congruent, okay? Same thing with this triangle over here. This triangle is also isosceles, 2 tick marks. So this has 4 arcs, so this one should have 4 marks too, okay? This one is also isosceles, so this has 3 arcs, so should this one. Down here, this triangle, okay, also has 3 arcs, so this should too. So these base angles. So all of these triangles within a rectangle are isosceles. So all triangles within a rectangle are isosceles. That's important because we know isosceles triangles have 2 of the same sides and the base angles are also equal. So then this side's different, this angle's different. Okay. And remember, all angles add all angles in a triangle add to 180. All angles in a quadrilateral add to 360. So just remember that, okay? So that's how I would mark up my rectangle. Now moving on down here to an example, I have to now start labeling stuff. So I have this quadrilateral ABCD. AC, this whole diagonal, is 4x minus 60. BD, this other diagonal, is 30 minus x. First, I got to find x. I know in a rectangle, my diagonals are equal. So I'm going to go ahead and set 30 minus x equal to 4x minus 60. I'm going to add x to both sides, add 60 to both sides. I get 90 equals 5x. That makes my x 18. The main question here, though, was what's AC? AC is labeled as 4x minus 60. So I'm going to go ahead and plug in that 18 for x. 4 times 18 is going to give me 72 minus 60. That's going to give me 12. Okay. Now I'm going to move on to the back side of the page, do some more examples with you. Okay, in this one, AR is 2x plus 3. BE, there is no E on here. I think this is supposed to be E. Sorry, typo there. Is 12 minus x. Find x and BD. So BD is this whole thing. So if that's 12, remember that all these diagonals are equal. So I can set these equal to find x. 2x plus 3 equals 12 minus x. But in order to find this whole thing, I just have to find one of them and then double it. So I'm going to add x and subtract 3. So this is 3x equals 9, so x is 3. Now let me figure out what half of these diagonals are, because I only have the halves labeled. So if I do 2x plus 3, I plug in that 3. That's 6 plus 3, so 9. So each little diagonal is 9. Okay, so that means that the whole thing, BD, one whole diagonal would be double the 9. So 9 times 2, which is 18. Okay. All right. For angle BAC is 4x plus 5. Angle CAD is 5x minus 14. And now they want to know what x is. Okay, this is something we didn't discuss on the last page that's also interesting. So I'm going to flip back and have you add one thing to this page, which is that all of these are right angles. That is important. Okay, so I want you to know that all of those are right angles. So that's one thing that we didn't discuss over here that is very important. These are all right angles. So that's going to lead me into solving this problem. Okay, this is a right angle, so I can go ahead and say 4x plus 5 plus 5x minus 14 should equal 90. Combine my like terms, so that gives me 9x. This gives me negative 9. And then that means I'm going to have 9x equals 99. So x equals 11. I still have to go ahead and find two different angles. So they want angle BAC. So I got to plug in the 11 to the 4x plus 5. So that's 44 plus 5 is 49 degrees. So angle BAC is 49 degrees, which then would make angle CAD, since they should add to 90, that would make this 41 degrees, because 41 and 49 add to 90. All right, let's get through this last problem. Okay, this last problem here I have BAC is 3x plus 5. And remember, it goes BAC, so it's this angle here. Angle ACD here is 40 minus 2x, ACD. Now, those are alternate interior angles, so they should be congruent. So I can just go ahead and set those equal to each other. I'm going to add 2x and subtract 5. So I get 5x equals 35, so x is 7. That's not the final answer. They want me to find angle ACD, which was the 40 minus 2x. So I'm going to go ahead and plug in my 7. It's 40 minus 14. 40 minus 14 is going to give me 26 degrees. Okay, so angle ACD is 26 degrees. Okay. If you have any questions at all with this, please reach out. I am available tomorrow and I will be doing video chats. Okay, have a great day.